Good evening. This is Evan Olivier, and this is a short presentation on the importance of water and life, water as a molecule. So first off, we'll talk about molecular polar covalent bonds. Water is vital to biology. The human body is made up of 70% water, but without many of the other properties of water, life would simply not exist. So let's go through a few of those. Hydrogen and oxygen atoms within H2O molecules form polar covalent bonds. While there is technically no charge to a water molecule, there is a small positive charge on each hydrogen atom and a small negative charge on the oxygen atom. This gives water its sticky, cohesive quality, meaning that each water molecule is attracted to other water molecules and also to other polar molecules like sugars. That leads to really incredible property of water called surface tension. These hydrogen bonds that attract water molecules to one another keep the water molecules together at the liquid-gas interface. This cohesion gives rise to another important quality of water, which is the surface tension. Some bugs, as you can see here, like the water skipper, are able to take advantage of water's surface tension to quickly float across the surface of the water, even though they are denser than the water, by spreading out their surface tension. And they never allow any one point to actually have enough weight or pressure on it to break through that surface tension. Another one is adhesion and capillary action. Adhesion is equally as important for life as cohesion. The attraction between water molecules and other molecules allows water to climb up from the lower root systems of plants to the tops of the plants. When you notice water climbing up a straw after placing the straw in a glass, this is adhesion. These molecules are attracted to the straw and adhere to it. You can see capillary action in this photo here. And some more characteristics that are rather important. You can see the water molecule here on the right. When a substance like sugar readily forms hydrogen bonds with H2O, it can then dissolve in the water and is called hydrophilic or water-loving. That makes a solution. So water is really an excellent solution for this exact reason, because water has a slight positive and negative charge. Ionic compounds and polar molecules are easily able to dissolve in it. The aforementioned hydrogen bonds in water also allow it to absorb and release heat energy more slowly than most other substances. So water absorbs large amounts of energy, and increased energy can easily disrupt these hydrogen bonds. Due to the rapid formation and disruption of hydrogen bonds in water, it can absorb an increase in energy while changing only slightly in temperature. So that inherently makes water a great temperature stabilizer. In this process of disruption and formation of hydrogen bonds, more bonds are destroyed than are formed, resulting in individual water molecules being released at the surface of the liquid, like a body of water or plants, and that's called evaporation. Without this property, organisms will not be able to sweat and cool their bodies through the breaking of hydrogen bonds that requires energy input and takes heat away from the organism's body in the process. So it's pretty vital to even the ability for us to regulate our homeostasis. And ice is also actually rather important for life. As you can see from this excerpt from our course textbook, the lattice structure of ice makes it less than the freely flowing molecules of liquid water. Ice's lower density enables it to float on water. So the converse of what we talked about on the last slide is also true, which means as temperature drops, there's less energy available to break the bonds, and they begin to form rigid structures as ice. Ice is less dense than liquid water, and this is because the molecules are further apart. So that means it's going to float on top of liquid water. The ability of water to become ice and float allows for life in cold temperatures to thrive by creating an insulated barrier that prevents the water life below it from freezing solid. And that is the importance of water as a molecule to the existence of life on Earth. Hopefully other places. Thanks.